So I think that most people have been able to log on. So with that, I want to welcome everyone to this webinar. I am Teresa Schell, and I'm really happy to introduce our first webinar in our series, where we look into details of the availability of alternatives to PFAS for specific uses. So we are choosing topics that are of special interest in the discussion of the universal PFAS restriction. And if you want further details on the process of the dossier, our analysis or other information, we have plenty of it on our website, and you can go there to check it out. And the recordings and the slides from today's webinar will also be made available afterwards. So today we will take on the area of technical textiles. Technical textiles belongs to the category TULAC, which stands for textiles, upholstery, leather, apparel, and carpets. So despite an abundance of alternatives in these uses, the TULAC category represents almost half of the EU consumption of PFAS. So the need for regulation couldn't be more obvious. Technical textiles are sometimes portrayed as hard to regulate, that there is not sufficient availability of alternatives. And with this webinar, we hope to provide information from within the industry of technical textiles on how this looks from their perspective. They are the real experts in the field. And that's why I'm really happy to present the panel that we have lined up for today. We have Dr. Louise Skedung from RISE, Louise Svensson working for the company Tranemo, and Dr. Rüdiger Fox, CEO of Sympatex. And with us, we also have our own Dr. Jonathan Kleimark, who will take part in the discussions. So after the presentation round, there will be an opportunity to ask questions to the panel. So please note down any questions that you have in the Q&A box below in Zoom, and we will do our very best to respond to them. So with that, I want to give the word to Dr. Louise Skedung. She is a researcher and project manager at RISE, Research Institute of Sweden. She has a PhD in surface chemistry and works with projects promoting PFAS-free alternatives and substitution of PFAS, including POP-free projects. Lisa.
Yes, thank you for inviting me to present here today. So my presentation will focus on newer methods to analyze products for PFAS content. And I will showcase this by a case study on workwear garments and shoes. So you can change slide. Just to see, RISE has coordinated the POP-free project, which is a series of projects that has worked with PFAS-free alternatives and communication to increase awareness about PFAS and the concerns. In the last project, POP-free industry, we had companies, partners in the project that were mapping their PFAS in their products and their assortment. And then we realized that we had to work with new methods in order to capture PFAS more broadly, because the question here was, do we have any type of PFAS in our products? And we also needed a method that could capture polymeric PFAS that many products actually contain that to provide a function. So you can change slide. So we worked with different analytical techniques, and we did find two very complementary techniques. The first one, they will quantify the total fluorine, so we can get the concentration of the fluorine content in the product, not the PFAS concentration, but it gives an indication on the PFAS content in the product. And then the second method is pyrolysis GCMS, which can be used to verify that the fluorine that you quantify actually is PFAS, that it's organic, and it also provides some structural information as well. So we thought to begin with, this was kind of methods to help companies screen whether they have PFAS or not in their products. But now we also think that both of these techniques are suitable techniques for future regulatory compliance if you think of the broad PFAS restriction. So we have analyzed different types of products, and this has been published in January this year. Both of these methods use direct thermal breakdown of the sample. So there is no extraction step before you do the kind of analysis, which we think are key to actually capture PFAS more broadly and the fluorinated polymers. So you can change slide. So both of these methods address the third concentration limit in the broad PFAS restriction proposal. So with the total fluorine concentration, we can compare that with the 50 parts per million. And as you can see, there is a text underneath which says that you may have to kind of show that the fluorine that you measure or don't measure is either of a PFAS or a non-PFAS. So that's also where the pyrolysis GCMS comes in to kind of verify that the fluorine is actually PFAS. So you can change slide. So this shows total fluorine concentrations in textile samples. So to the left, you have 5 fabrics where we know that this treatment is a side chain fluorinated polymer. It consists of 6 fluorinated carbons. So you can see that all of those fabrics have a concentration over 50 ppm. And then we have the exact same fabrics, but with the fluorine-free treatment instead. And you can see that the concentration is then less than 50 ppm. And then to the very right, we have unknown textiles where we don't know if there is PFAS or not in the sample. So based on the total fluorine concentration, we can assume that the 2 first samples there, products, do contain intentionally added PFAS. But we don't know for sure, because in the total fluorine analysis, we will get both organic PFAS and inorganic fluorine. So that's why we have the pyrolysis GCMS. So with this, I just want to highlight that the 50 ppm level in the restriction proposal makes sense. So you can change slide. So then we have this this method, which is a common method to analyze materials and polymeric materials. And you also here, you put your sample or a piece of the sample and you combust it, you pyrolyze it. So you create smaller fragments out of the material that goes through the GC column and then hit the mass spectrometer. So you can get kind of fragments that elutes at different times. So when you analyze this type of data, you can look at the retention times where the fragments do elute. And you can then look at the mass spectra in each of these peaks. And you also have an instrumental database that you can kind of help you guide what type of chemistry it is. So you can change slide. So I want to showcase this on a study that we have done on workwear garments and shoes. So assume that this is, you can see this as a case study of a future enforcement of a broad PFAS restriction. So the question is, do we have any PFAS in these products or not? So we had 23 commercially available workwear garments and shoes. And out of these 23, 10 of the garments and 3 of the shoes displayed a total fluorine concentration over 50 ppm. And this range was between 65 and 1,500. So this range then indicates that these 13 products do contain intentional added PFAS. So going further with pyrolysis GCMS, we could actually verify presence of PFAS in all of these 13 samples. And you can see two types of chromatograms in the bottom to the right. So out of these 13 samples, we could find a C6 side chain fluorinated polymers in 10 of them. But we could also find a C8 side chain fluorinated polymer in 3 of the samples. And the C8 technology should not be used since we have the POPs restriction. So how could we conclude that this is C6 and C8? So then to help us, we have to showcase this, we have reference textiles to the figure to the very left, where we know that this is a treatment with 4 fluorinated carbons, 6 fluorinated carbons, and 8 fluorinated carbons. So you can see that they elute at different times, and the chromatogram looks slightly different. So if we then look at our chromatograms from our unknown samples, we can see that the mid one have a PFAS fragment at 1.7 and 7 minutes. So we, based on that and how the mass spectra looks in these fragments, we can conclude that this is a C6 side chain fluorinated polymers. And in the same way, we could conclude that 3 of the products did contain a C8 side chain fluorinated polymers, because we could see that the PFAS fragments corresponded to our C8 textile reference. So you can change slide. So this is just, if we take one of these textile samples and we analyze it with different analytical techniques. So in the first row, you can find the sum of target PFAS substances. So we do the traditional target analysis. We quantify specific, in this case, 22 specific PFAS compounds. And then the total sum is 15 parts per billion. And this is way below the 250 ppb in the restriction proposal. And then if we do extractable organic fluorine, basically you analyze it, you quantify the fluorine, but you have an extraction step before you do the combustion and you quantify the fluorine. And in this case, we are under the limit of quantification. But if we instead do direct combustion of the sample, we get the total fluorine concentration of 1,500 parts per million, which is way above the 50 ppm in the restriction proposal. So what this means is that depending on which analytical technique that you use, you will get different answers. And the answers would either tell you that you would pass or kind of fail the concentration limits in the PFAS restriction proposal. So we highlight the total fluorine as a suitable screening for intentional added PFAS. So you can change slide. So I just want to highlight that this showcase how we have used it on textiles. But we have also, it also works for fluoropolymers. The textiles contain side chain fluorinated polymers, but we have fluoropolymers such as PTFE, PFA, FEP, ETFE that are examples of fluoropolymers. And this figure shows the total fluorine concentration in plastic, electronic plastic. And here the concentrations are about 2,000 ppm. And in all of these 3 samples, we could verify with pyrolysis DCMS that the quantified fluorine originates from the fluoropolymer PTFE, which is used as an anti-dripping agent in plastic at very, very low concentration. So you can change slide. So to summarize, analysis of total fluorine with combustion ion chromatography and pyrolysis DCMS are promising and complementary analytical methods to screen products for intentionally added PFAS. So these methods can help companies understand if they have PFAS and what type of PFAS they have in products. But we also think that these methods are suitable for future enforcement of a broad PFAS restriction. Both of these methods capture PFAS broadly. It doesn't necessarily say exactly which PFAS it is or that has been used to make the polymers, but you can get it captures whether you have PFAS in the product, and it also captures polymeric PFAS, which there has not yet been a good analytical method for. This presentation has focused on textile products, but the methods have successfully been used also to screen for PFAS in cookware, electronic products, food contact paper, ski wax, and hygiene products, for example. I also want to highlight that if you get a total fluorine concentration over 50 ppm, but we don't see any PFAS fragments in the pyrolysis GCMS, it may indicate an inorganic source of fluorine, because we have seen this in several different products that you have inorganic fluorine that can, if you would only do the total fluorine, you would get the false negative or false positive. And just to say that the traditional analytical techniques, the top target analysis is needed to check compliance today. The POPs regulation and the carboxylic acids, and those are needed to find lower concentrations such as impurities and contamination in products. So that was, thank you. And if you have any questions about what I presented, or if you are interested in PFAS analysis, feel free to contact me.
Great. Thank you so much, Lisa, for that presentation. And with that, I want to hand over to Louise Svensson, who is a textile engineer. She's worked within product development of personal protection equipment garments for 17 years. She's now at the company Tranemo, with focus on developing inherent flame retardant garments for different segments that needs PPE. And she's also part of the SIS standardization work on the subject as a Swedish expert. Sorry, Louise.
Thank you. Okay, we can continue to the next slide. Tranemo is a family-owned company, third generation. So next slide. This is, you can change slide again. Yeah, thank you. This is our customer segments that needs PPE. PFAS and PFAS-free finish is mainly needed for chemical protection in heavy industry, like melters and foundries, in mining, or in chemical and petrochemical industry. This customer has the chemical protection as a second risk. As an example is our molten iron customer. Molten iron with a melting point of 1500 degrees is the main risk. And then some users handle sulfuric acid and then need chemical protection. Next slide, please. At Tranemo, we only work with inherent flame retardant fabrics, then basing the flame retardant or the FR function in monocrylics or the viscose fiber FR lensing or aramide fibers. And these fibers are then mixed in different fiber mixes in the fabrics. And the protection cannot be washed or worn out, but the PPE industry use PFAS in a lot of garments, something that is negative effect on the environment and health. Next slide, please. Today, PFAS is used in normal workwear and high-risk workwear as a dirt and oil repellent or as a water repellency. It is used for limited chemical protection or to increase the arc rating of flame retardant function for electric arc garments, then using a PTFE membrane that includes PFAS that Lisa mentioned. Next slide, please. For high-risk garments, certified 2471, PFAS is used as a dirt and oil repellency on the high-risk yellow fabric, not on the reflective stripes. Tranemo did a study. So on the top picture, it shows a high-risk FR trousers with on the left leg, we have a PFAS C6 finish, and on the left leg, on the right leg, we have no finish. So we had a user that gets really dirty when he works, as you can see. So then the below picture, you see the same trousers after 60 degrees washing. So Tranemo's conclusion, PFAS is not needed for oil and dirt repellency. Garments needs to be washed regularly to be safe, since dirt affects the flame retardant properties. Next slide, please. Protection against the chemical splashes and EN 13034 certification requires that the fabric has a finish. So the biggest challenge out of these 4 certifications, moving away from PFAS, is to reach a limited chemical protection. Next slide, please. In the standard 13034, 4 chemicals are tested to represent 4 different chemical groups. It's acids, alkalines, aromatic hydrocarbons, and alcohol. But then only 1 chemical has to pass the requirements to be able to CE mark the garments. Apex on the top picture is Tranemo's Aramide series, where there we have a PFAS C6 to reach to pass all 4 chemical groups. Below you have the Cantex Well Stretch, that is Tranemo's first FR series with a PFAS-free finish that passed acid and alkaline, and this was launched in 2021. Next slide, please. Now Tranemo is changing our big Terratex collection to PFAS-free. Here you can see that we offer the same level of protection for acid and alkaline when using a PFAS C6 or a PFAS-free finish. Since none of our customer is asking for protection against oxalate and butanol, we took the decision that we will make most our garments PFAS-free. And then for customer asking for 13034 certification, we always ask, what chemical do you need protection against? So PFAS-free, PFAS finish and PFAS-free finish should be handled by a professional laundry when it comes to PPE and 13034 certification. Next slide, please. Tranemo has done cross-impregnation on our FF fabric with finish. What we mean is that the fabric impregnated with PFAS C6 is re-impregnated with a PFAS-free finish, and then tested at the institute according to the standard 13034 and the other way around. So the results show that our fabric do not lose their function. It will still pass the standard 13034 even if it has been cross-impregnated. So if the garments are only certified against acid and alkaline, the laundries can choose whether they prefer PFAS or PFAS-free re-impregnation on the garment that's in their laundry system. This is something that Tranemo sees as a big step in the work towards a PFAS-free future, to also give the opportunity to the laundries to choose a more environmental friendly chemical. Tranemo has also done tests together with our laundry customer at end users to also test the 13034 function on the end users in the end users working environment. Next slide, please. In this movie, you will see a visual comparison between the fabric with a PFAS, a C6, and with a PFAS-free finish that shows the relationship between the surface energy of the fabric and the surface tension of the liquids is the thing that determines the ability for the fabric to repel. Water with a high surface tension can be repelled by a PFAS-free finish or a DWR finish, that stands for durable water repellent finish, which has a low surface energy. The PFAS-free finish has too low surface energy to repel oil with a low surface tension. So to check if a PFAS-free finish repels chemicals like acid and alkaline, the chemical with a higher surface tension than oil can be used. Next slide, please. And here you see a picture of the same thing I just explained. So next slide, please. Both PFAS and PFAS-free finish needs to be reactivated and re-impregnated. And this needs to be done to get the protection to last. It needs to be handled by professional laundry for 13034 certification protection. Most important is the reactivation over 70 degrees to postpone the number of time that you need to re-impregnate the fabric with a finish and to add more chemicals. Compared to PFAS, that is a forever chemical, the PFAS-free solution we use has a chemistry that is more similar to the chemistry in the nature, where leaves naturally repels the water droplets. Next page, please. So to encourage this change, that this change is needed, let's take the example of my colleague Tilda, who's born in 2000. Next slide, please. So this is Tilda, that is part of the generation set, and pictures of different things she likes. The map on the left is the PFAS contamination in Europe, known and expected. Next page, please. So it doesn't help if Tilda only do what she has to, because product containing PFAS leaks dangerous substances throughout the life cycle, and the chemical spreads further in nature, including through groundwater and drinking water. Next slide, please. Which means that Tilda will always be exposed to PFAS all the time in her everyday life. So we have to move forward. Next slide, please. So since 2020, Tranemo has actively worked to phase out PFAS. And finally, Tranemo feels like we have made it to the point where our customer now is asking us for a PFAS-free alternative. Next page, please. In 2015, we left the use of PFAS C8. In 2020, we took out all the PFAS from normal workwear and high-vis workwear. And then under 2024, we are moving over most of our flame retardant fabrics to PFAS-free and are cooperating with our laundry customers so they also can make this change. Next slide, please. So, and we hope it continues that way so we can stop using PFAS where it's not needed. So thank you very much for listening in, and stay safe and healthy.
Thank you so much, Louise. And just a clarification, we had a little mishap in the beginning with connecting her. So when that it said that she was Anna Lundqvist, that is, as you can all see, not true. That is indeed Louise Svensson. So then I want to move over to our final speaker, Dr. Rüdiger Fox, who is CEO of Sympatex Technologies. He has experience from leading medium and large corporations in aerospace, telecom, textile, and engineering and innovation. And with Sympatex, he currently engages to pioneer the accelerating transformation process of the textile industry towards sustainability and closing the loop.
Yeah, thank you, Teresa. And first of all, thank you everybody to join and the invitation. I might have a slight tendency to go a little bit philosophical in the closing presentation, basically building on what you have seen before. But perhaps to give you a big idea, we are in the membrane textile business in principle, but we have our understanding that we are more than a membrane because we try to look at what is our business doing in the larger context. We work since 35 years in the business with a PFAS-free membrane, and I come quickly to show you the two critical points of our applications. And we work since 15 years with C0 DWR alternatives, which is basically the water repellent coating. Textiles don't need to be waterproof, but they basically need that to avoid that the garment soaks in on the outer layer humidity. Next slide, please. So the range of our application comes from classical outdoor apparel applications in snow, as much as hiking, going up to motorbiking. In the footwear area, same or similar applications. up to using that knowledge in apparel and footwear in the workwear area. And I think looking at those three ranges, we obviously started from left to right in looking at what are actually the needs for PFAS. But there are many two critical areas which we needed to look at in those functional applications. Next slide. Basically, the core of the product is in its function pretty independent on the final application, whether we look at fire protective equipment, whether we look at outdoor gear. We try to protect the user from water coming in or from liquids coming in, while the humidity from activity can help to, or the membrane system helps to bring the humidity out. And there's a long tradition and a big market where actually two main applications refer to PFAS materials. The one on the right side, the mentioning, the number one is a membrane. The membrane is this very thin layer between the outer and the inner textiles that basically serves in the core function of our products. And that core function is, as I said, protecting from water coming in from the outside, and at the same time transporting humidity from the inside to the outside. And there's a range of pretty much three different materials, but the dominating material for decades has been a PFAS containing PTFE membrane, where the main concern is not only for the user, but actually already in the release during production. We have run a pretty extensive study on why especially PTFE is one of the critical applications / the unnecessary applications in our industry. And we can provide that study, whoever's interested, also after the call. The second application, as I said, is the so-called DWR. So mainly the outdoor industry and other industries has started to move over the last years from C6 to C8. I tend to say, being not a chemist, that's pretty just making the problem a bit smaller, but continuing to spread it doesn't change anything at the impact. The release here again is mainly in the use phase, but also during landfill, and we also did studies from the incineration, because what we all need to recognize is that a lot of garments still end up in incineration at the end of their lives. So I think we need to look at the PFAS challenge really in the entire lifespan, from the creation of the product to the user phase and to the end of life. When we approached this, and as I said, on the membrane, we had a decent history of 35 years when we became aware of the consequences on the DWR and on PFAS in principle. We focused on both areas at the same time. Next slide, please. And mainly thank you. And mainly worked since 35 years with a membrane that is polyester based, so PFAS-free. And in the last 15 years, we really focused on replacing DWR with zero alternatives. And in all honesty, and we saw it in the presentation before, there are, especially with regards to stain resistance, there are inconveniences. And that's a little bit of the philosophical part I want to bring in here, because I think we need to start asking the right questions. We have decided to phase it out as a principle. We haven't said, okay, let's see where we can phase it out and where we can still keep it in, where it's needed, but we defined for ourselves the clear goal in exiting a chemistry that us perhaps are only to a limited extent exposed, but that accumulates from generation to generation. And our core question is, what is actually the justification? Or in other words, next slide, please. Try to explain to a 5-year-old why we have the right to pollute his future, just, for example, to avoid traces of stain in a workwear gear. So my personal honest belief, and that is 8 years now, trying to demonstrate, not only in our own products, but demonstrate as much as we could, that when you ask the right question, when you start from a no to PFAS and try then from that limited license to operate, that we can look at what are actually solutions we can find to comply with that, let's say, ambitious goal, perhaps at first sight, but more a fundamental justification we all need to do our jobs. I think that is really the core question. And to be honest, yeah, it was mentioned, I spent quite a lot of time of my career before I joined Textile in the aerospace industry. Aerospace, or if you look at products and prevention and all those aspects, this is mainly from a place where you need to look at worst case scenario. We're looking here when we look at, I admit this is the main functionality is water protection. So worst case scenario here is somebody gets wet. Where's the justification of putting out chemistry or using chemistry that at the end of the day will actually be left to the next generation that doesn't even have a voting right in the discussions with her here. So from this one on, that was actually our ambitious position where we said there's just no license to operate using PFAS. And then we can look at where are actually limits or perhaps the gray zones of application where we need to be innovative and go further. Next slide. So, and I skip a bit the apparel application and the outdoor shoe application because this is kind of obvious. There's no case scenario. We need to see how far we can get. So the focus in the recent years was really looking at personal protective equipment. And you see an extract of a study we have run in pretty much all the potential applications. So it's protective equipment for the outside where you could be exposed to humidity, to water, to rain, to whatever. And the first realization we had, and that is the classical darker greenish part and the lighter greenish part, 3/4 of the application. It's just blank clear. We don't need PFAS. There's a range of applications where there are solutions in place that with a reasonable approach, we can say they serve all the requirements, not necessarily in the specification, and they come instantly to the specifications, but that serve all the true requirement of an application. And admittedly, and that's the orange part, and we purposely didn't color it in red because we felt also in the orange part, which is typically military, which is typically firefighting and others, we need to go and look a bit closer. Because honestly speaking, if a boot of a fireman reaches the specified temperature of 220 or higher degrees Celsius, this guy has a different problem than the melting of a membrane of 25 micron thickness in his shoe. So what we call really is that we have a constructive discussion on the specifications. Those ones we see so far in many applications are highly exaggerated and honestly speaking have at least give at least the impression that they serve more as a justification to keep PFAS in place rather than to really look at what is the need of the end user, the need of the application. So that's why we believe only a really strong limitation of any derogation for cases where it's proven that the specification really serves the end user, saves the life of the end user, and is not just to justify previous chemistries we were using. These are the only areas where we need to have a discussion and perhaps derogations. Otherwise, we believe a fundamental ban is really helpful for us all, because in our experience, the more we were clear in our requirements, clear in all the boundaries of action, we realized that's where innovation actually happens. Innovation is not free creativity. Innovation happens between clear boundaries when we can focus the industry. So next slide, please. So again, we can share that study. We have run really going in all the different applications. On all those applications, we went into the norms in the all the listed here, or this is an extract in all these requirements, and we really figured out that in, I don't want to say all because that's a bit too absolute, but in most of the applications, they are really reality check to specification will allow us to enter with non-PFAS solutions. And I think the real approach we need is we need to ask the question differently. We need to stop trying to find exceptions to specifications. We need to search whether these exceptions are really to the real end life applications where those materials will be used. Next slide, please. Just to, and this is not to show off, but to give you a bit of range of clients we are serving since many years with PFAS-free solutions. So there's really a large amount of applications where we have already proven that PFAS-free is not a, let's say, a long-term goal, but is something we can put in place. Next slide. So our core principles, and that's the kind of philosophical approach we have been taken, and we feel that that has helped us to be more radical, but also to find solutions much faster. We believe that constraints might really be a challenge to creativity, but at the end, for innovation, it actually helps. The moment where we don't check how to compare PFAS containing and PFAS-free materials, but are clear on the approach we're taking, it will bring us access to innovation we probably wouldn't have found so quickly otherwise, because you create almost a desperation for innovation. I think the next second important decision we have taken is we look at good enough. We really try to understand what is the water column, what is the temperatures, what is the flexes, what is the lowest temperature performance that in field is really used. So we rather go away from traditional overspecification in some cases that are more to let's say keep status quo. We really challenge those, and we figured out that in many applications we can find construction solution in the garment, and we go on those garments up to final construction where we can actually prevent that perhaps a let's say temperature-wise more challenging material than PTFE can serve the same purpose without any concessions to the life or the safety of the end. And lastly, we try to really understand responsibility, not towards the law, but towards the transgenerational responsibility, because that's at the end probably a little bit the weak point of our today's democracy, that the voting rights are at the moment still giving to us, rather than those ones who need to live with the leftovers of our industrial actions at some point. So in a nutshell, and that's the last slide, I think, the next one. In a nutshell, we really call for comprehensive ban, and then it's a level playing field for everybody, where even PPE is extremely limited to any derogation, and only if it's really purpose cost and application cost, and not simply by over-specifying those requirements. Thank you.
Thank you so much, Rüdiger, for that, and thank you to all the panelists. We will now have some time for Q&A. We're slightly behind schedule, but we will continue for a while anyway. It was really interesting presentations, so we allow for that to take some time. So the first question is to Rüdiger Fox, but I think it can also be asked to Louise. And it's about what kind of reactions have you gotten from customers about your no to PFAS approach?
Yeah, I think it's, I would say it's mainly positive, but it feels like we've been working on this a long time, and it's taking some time before they actually ask that question. So, but now it's coming more and more, so we see that as positive, because we think it's very important to move away from PFAS. And we see solutions like Rüdiger also talked about.
And what about you, Rüdiger?
Yeah, I was a little bit smiling because, but I think, and this is perhaps a management strategy I lived through about 20 years ago when we're looking at customers' questions, needs, and so forth. And it's the right question. But I think the first question we need to ask ourselves, what gives us the license and the permission to do what we're doing? So it wasn't a driving question for us at the beginning that we checked this class. We didn't care. I think it was the right decision to take. We have seen actually a lot of skepticism. We have lost business. We still struggle to expand in those areas where especially specification guide procurement. It was easier in non-PPE application, but we are all humans. Buyers of our customers are humans. And convincing humans to change something is always more effortful and pretty annoying. So changing specification, reworking specification has been probably the biggest hurdle we have seen. We were not welcomed with this, but we keep talking about it, and we see there's a slight generation move step by step. I think what makes me really enthusiastic is that we have a different language today. When we started 8 years ago, or even before, it was more like, oh, which PFAS and which one, and needed to justify every single one. We reversed the justification process. And for me, this is the indication that those customers who don't buy in might be actually left at the train station when the train is gone. The market has changed, the awareness has changed, and luckily there are new generations coming in that tell us and show us what we should not do anymore.
Yeah, thank you so much. We have a bunch of very technical questions for Lisa. So I've tried to bundle a little bit together, and I'm sure we will share with you afterwards, Lisa, the questions you get, and I'm sure you will be contacted after the webinar also. So what do you think about the other analytical techniques? TOP is important for identification, as mentioned. Maybe you can clarify a bit about that technique, and what about other technologies such as NMR or IR?
So I can summarize, because we have tried different techniques, and I can say that FTIR works very well, like to really see whether it's a PTFE coating in cookware, for example. But the challenge with FTIR is that it kind of measures below the coating layer, so it measures down in the bulk. So it's not as straightforward to use FTIR if you don't have like the reference with and without the treatment. Solid state NMR we have thought of. We have not tested it, but I think it could be interesting to try that. And I also saw that there was a question about TOF, which I think is total organic fluorine. And I think there's I'm not sure whether that phrase is kind of used as another phrase for total fluorine, but I think that there is a big risk that if you do an extraction step before you do the combustion, you might miss PFAS substances, especially the polymeric ones. So I think depending on if the TOF, how it's done, but I think one have to be a little to see how it's done, because we have got samples that have passed, but then we can find PFAS with our method. So I think there's I'm not sure if it's used, like how the phrase is used.
Good, thank you. And Jonathan, maybe you have some comments on that as well. I don't know.
Yeah, I can just add that I know that NMR is something that is being developed by several companies. I know that it still has some issues regarding the detection limits and things, but it would also be a very powerful method, I think, to more generalize how you can analyze for PFAS. So I think there is a lot of research being done for these new techniques, and I think that in the coming years we will see a lot of development.
Yeah, thank you. I have a more general question and more towards the companies. What level of assurance do we have that the PFAS-free alternatives provided by your companies do not contain substances that may harm human planetary health? I don't know who would like to answer that. Maybe Louise?
Well, I mean, I think that's a good question. We know that we're not using fluorine in the cold chain that we know, and we know that the chemical chain we use looks similar to what nature used, but of course this also needs to be studied and follow up. And I also think that the awareness around the protection we sell is something that Rudiger also mentioned, that some customer that would put all certification on just to be sure that they protected. So you need to really narrow down what you need to maybe rule out even to have a finish at all, because that means less chemical, which is also positive. So we would also like to move towards using less chemical in general, not on putting PFAS-free on everything. So still work to do, I think. You have to knowledge and learn more. So that's what we try to do.
Thank you. I don't know if Rudiger has something to complement.
Yeah, if I may, I think it's a wonderful question, because that's a question every time we try to improve something. And probably the sad part of human history is that the moment we change something, we don't know everything that could happen afterwards. And most of the time, we actually haven't seen things because they weren't visible. So I think we can never say for sure that there are downsides of improvements. I would just say those ones, the downsides that are obvious, are the ones that are related to PFAS, and ignoring this with the theoretical risks that there's something new emerging at some point, I think that's worth trying. So that's we cannot exclude for 100% sure, even though, yeah, rightly, it's a nature emulation or nature product, so we believe we're pretty close. Side effects is probably nothing on the world anymore that has no side effects, but we see the huge benefit, at least on those things we know. And doing something consciously knowing about the downside, I think is worse than doing something where we don't know yet could be at some point the downside. So the answer is we don't know, but there's a high level of confidence we're having there's probably nothing. And definitely we're 100% sure it's better than continuing.
Yeah, thank you. I think we have time for one more question, and then we have to close this. But there is a question on how big market share do the PFAS-free alternatives for technical textiles have today? And I guess, this is going to be a bit of a guess for everyone. And I think, Rudiger, you're already attempted to answer that question slightly. So I open the floor to anyone. Maybe you want to start, as you already went into that.
Well, I would say, as a pragmatic optimist, I would say the improvement potential we have on hand and the low-hanging fruits are huge. I think the market share is probably ridiculously low compared to what we could do today. So if somebody looks at it economically, there's no better growth trajectory you can have than going PFAS-free.
Thank you. Is there anyone else who would like to comment that before my concluding remarks?
I just agree with Rudiger. It's hard to put a figure on it. We just try to promote that our customers choose the PFAS-free or no finish solution. So we try to encourage them to make better choices.
Great. Thank you, everyone. I've tried to make some notes after listening to you and trying to make some conclusions. So to me, clearly addressing the replacement of PFAS in technical textiles requires a more nuanced approach to functionality, which several of you already went into. And I mean, the reason for the universal PFAS restriction proposal is not to create problems, but to address the imminent need to stop this PFAS crisis that we see on a global scale. And when we have dedicated companies and dedicated people looking to solve the problem rather than making circles around it, solutions are found for the vast majority of the users, even though it is difficult to set a number on it, clearly. So at least I have learned today that much of the use is avoidable. Very little actually requires the PFAS today, but still there is this perception that it is needed. PFAS solution for technical textiles are not a one-off solution. That's important to remember, that they also need reactivation and retreatment. And dirt repellents is better achieved by washing. That was really interesting to see. And that PFAS might not even be solving that problem to start with. There will be uses clearly where the functions requires PFAS, where there are not yet available alternatives, but these cases are not everything. So we need to be very precise when we talk about the derogations, both in use and in time. And to me, I mean, it's so nice to hear that the movement away from PFAS in the industry is really ready. But there will be no real change without the PFAS restriction. So to keep that going is super important. And with that, I, from the bottom of my heart, want to thank all the speakers today and take the opportunity to talk 1 minute about our next Beyond PFAS webinar that will be about F-gases on the 28th of May. F-gases are responsible for over 60% of the PFAS emissions. They are used extensively in air conditioners, for refrigeration, in your heat pump, car, and in many other applications. Alternatives with proven performance have been around for a long time and are in many cases even cheaper and more effective. So look out for the webinar invitation that I think will be coming next week to find out more about the companies and solutions to be presented. I hope to see you all then, and thank you very much for today.